So now let's talk about fine-tuning on Amazon Bedrock. So fine-tuning is going to be a big part of your exam. So the idea is that you're going to adapt a copy of a foundation model and you're going to add your own data. So when you fine-tune a model, it's actually going to change the underlying weights of the base foundation model. So you need to provide training data and it needs to adhere to a specific format and needs to be stored into Amazon S3. So the idea is that, for example, you have the Llama 2 model and you're going to add data from Amazon S3, such as this data or that data. And we'll have a look at this data very specifically in the next slides. And then Bedrock is going to do its own thing and you're going to get a fine-tuned version of Llama 2, which has your own data as well. So in order to use a fine-tuned custom model, you must use what's called provision throughput, which is a different pricing model than on-demand. And note that not all models can be fine-tuned, but few can, and they're usually open source. So how can we fine-tune a model? Well, we have instruction-based fine-tuning. And here, this is to improve the performance on the pre-trained foundation model on domain-specific tasks. So what does it mean, domain-specific tasks? This is something you'll see at the exam. That means it's going to be further trained on a particular field or area of knowledge. And here, the trick you need to go and look for at the exam is that instruction-based fine-tuning is going to use what's called labeled examples, and they're going to be prompt responses pairs. So it's for labeled data, and the prompt response pairs look like this. The prompt is, who is Stefan Marek, for example, and the completion, so the response is, Stefan Marek is an AWS instructor who dedicates his time to make the best AWS courses so that his students can pass all certifications with flying colors. So here, on top of giving information to the model, we are also showing the model how we want it to order some questions, such as who is Stefan Marek. Maybe the answer the model had would be already similar, but with a different tone. So this is where instruction-based fine-tuning is helpful. Next, we have continued pre-training. So here, the idea is that we continue the training of the foundation model. So here, because we know foundation model have been trained using unlabeled data, we need to provide as well for continued pre-training unlabeled data. And so this is something you look for in the exam. If you have unlabeled data, this is the kind of fine-tuning you need. And so it's also called domain adaptation fine-tuning, to make a model an expert in a specific domain. For example, I'm going to feed the entire AWS documentation to a model, and then the model is going to be an expert on AWS. So here, we're just giving all documentation. It is unlabeled data, so this is continued pre-training. And now the model has become a domain expert. So here's the kind of input you have. Here, as you see, there's no prompt output. There's just input. And the input is just a lot of information. So here, this information is around financial data. And as you can see, if you want to read through it, it has a lot of acronyms. And so this is very good to teach acronyms or feed industry-specific terminology into a model. And then you can keep on training the model. It's called continued pre-training as more data becomes available. Okay, next you may encounter as well single-turn messaging and multi-turn messaging. So this is a subset of instruction-based fine-tuning. But the idea is that here we're going to give a hint into a user and an assistant, what the user is asking and what the assistant, so the bot, should be replying. So here we have system. This is optional context for the conversation. Messages, which is going to contain various messages. Each will have a role, which is the user or the assistant, and the content, which is the text content of the message. So here we're fine-tuning how a chatbot should be replying. And for multi-turn messaging, this is the same idea, but this time we have a conversation. So we have multiple turns. And so here we alternate between user and assistant roles, and we have a conversation. And this helps the model understand how to handle conversations with bigger context. So good to know for fine-tuning. First of all, retraining on financial model requires a higher budget because you need to spend some computations on it. So instruction-based fine-tuning is usually going to be cheaper because the computations are less intense and usually you have less data required. You're just trying to fine-tune how the model is replying based on specific instructions. If you use continued pre-training, it's usually more expensive because you need to have a lot more data. Also, it requires you to have an experienced machine learning engineer to perform the task, even though Bedrock makes it easy for you. And you must prepare the data, you must do the fine-tuning, and also evaluate the model. And finally, because you have a fine-tuned model, It's also more expensive because you have to use provision throughput. So the use cases of fine-tuning is, for example, to have a chatbot designed with a particular persona or tone, or geared towards a specific purpose, such as assisting customer or crafting advertisements. It's also to have train it out more up to date than what the model previously accessed. Also, is to train it with exclusive data that you have only, for example, historical emails or messages or records for customer service interaction. Of course, base foundation models do not have access to this because this is your data, and for targeted use cases, such as categorization or assessing accuracy. So let's say for fine tuning, the exam will ask you about when fine tuning is a good idea and the kind of fine tuning you will need based on the type of data you get, for example, labeled or unlabeled data, as well as maybe some pricing questions. All right, that's it. I hope you liked it, and I will see you in the next lecture.